SSH keygen supports multiple types, including RSA and DSA, used for version 2 of SSH, and RSA-1 for version 1 of SSH. SSH keygen with help will tell you what's supported. However, it comes back, it's ready to generate the key pair, and by default it generates RSA. So if we kill this process and man SSH keygen, as it is a Perl script, and it throws an error there. So we'll just move forward in SSH keygen, type RSA. This will attempt to create a public key, private key pair, RSA key pair. You could indicate DSA or RSA-1. Those are your other two options. The process creates beneath the hidden SSH directory, similar to GNU Privacy Guard, two files. A secret file known as ID_RSA, which doesn't have a suffix of pub or priv, and will also create a public corresponding file named ID_RSA.pub. Just like with GNU Privacy Guard, you have the option of protecting the secret key using a passphrase, such that anytime you intend to or attempt to use the private key, you'll be prompted for the passphrase. For all intents and purposes, we'll avoid assigning a passphrase so that we don't run into problems with using the key at a later point. Now here we see an error was thrown. This leads us to believe that home student 1 SSH doesn't exist, or there's a permissions issue with home student 1. Let's check it out. We'll lsltr home, and we see student 1 is owned by student 1. So let's try it again. We'll SSH keygen, type RSA, and this will attempt to save it in the home, and it threw an error regarding the inability to create the directory home student 1. Now this could also be an out of space issue, so that's df-h, and it doesn't appear to be, as the home partition is mounted on a hard drive that has 28 gigabytes free. So let's grep student 1 from etc password to see where the user's home directory actually resides. And again, it is in home student 1. A mount will reveal how home is mounted, if it's mounted independently of the / or the root file system, and it isn't. So it is a part of the root file system, which is writable. And one other point which comes to mind is that this is probably related to a quota isse, since we have enough space. So with that said, let's SSH to our remote system that we have, 192.168.75.199, and attempt it there, as we don't have a quota issue in place. We'll SU in as student 1, then SSH keygen. Because again, it doesn't matter which system we create it on, so long as we create it and show how it's used with respect to passwordless logins. So on remote system, student 1's home directory is located beneath home 1 in student 1, and the directory was created, so we'll assign no passphrase. And very quickly, unlike the GNU Privacy Guard process, a public key as well as a private key have been created, and the fingerprint of the public key is as follows, which is unique to the user's public key. The email address auto-assigned is a derivative of the host name as well as the user's login name, which GPG prompts you for. So as this user, if we log into or change into the SSH directory, we'll see two files. One is a secret key. That's the ID_RSA file. And that's a secret key for OpenSSH v2 and for the RSA algorithm. The other file is the public key, and we see that the comment surrounding the key indicates that it is indeed a private key. The other file is a public key. This is the key that is to be shared with remote systems. Now with respect to passwordless logins, after we've generated a key, set up passwordless logins using SSH. This is where we can use the SSH copy ID program that's included with Redhat Enterprise 5 as well as SUSE Enterprise 10 and other distros, including Debian 4X, SUSE Pro, you name it. if we SSH copy ID -I followed by the path to the public key, which is located beneath the user's home directory beneath hidden SSH as ID _ RSA.pub, if we copy this to a desired user on a remote system, such as root at 192.168.75.10, for subsequent logins, the user student1 on the remote system will be able to connect to Linux CBT serve1 as the user root. Whether or not that's desired is besides the point. The point remains it's doable. So this prompts us to accept the public key of Linux CBT serve1, which stores the public key of the remote server in the local known_hosts file. We'll indicate yes, and now the remote system's RSA public key has been added to our permanent list of known hosts, which is a file named known hosts. At this point, we'll have to authenticate using password authentication. Providing all has gone well, we can echo the exit status to see. If a 0 is returned, all appears to have run well. We can now try to log into a remote system using what you see here. So as student1 from the remote system will SSH as root to 192.168.75.10, and this will allow us to log in without being prompted for authentication. We'll exit, turn on verbosity, and you'll see that along the way that passwordless login was used. And if we scroll through the trail, we'll see that the SSH client on the remote system read the global file. It applied options from asterisk. The global file supports options on a per user basis if you so choose. It searched for an identity type and it found an identity. By the way, your secret key is also known as your identity in both GPG as well as SSH. So it found an identity for ID_RSA. This identity file you see here, or the reference to this identity file, is for RSA version 1, which is an older, more crackable version of RSA encryption algorithm. So ID_RSA was found. This is the secret key which is used to decrypt communications encrypted with our public key. So 3 keys, or the key was found, 3 keys were loaded, and later on you'll see that passwordless authentication was used to connect to the remote system. And that's towards the bottom. It tells, or it says below, that it tries various authentication methods. Here are the methods that can continue. Public key, which ultimately worked, password authentication, etc. And below we'll see that the method that actually succeeded was public key, and this key was tried but failed, but the version 2 RSA key was tried and it worked. So with that said, we have a passwordless authentication based on the public key for version 2 of RSA, and we've connected to the remote system with no trouble whatsoever. We exit, we see how many bytes were transferred, any errors, so on and so forth. So passwordless authentication is relatively straightforward to implement. Now regarding the global configuration file, any user can read the file. Let's navigate into etc/ssh, where there are a bunch of files, including the global client as well as global server config file. A less of SSH_config reveals directives that all clients, all SSH clients that we've covered, process, including a default asterisk section that's processed by all of the clients. We see defaults that are set. All of these items that are commented are the defaults, whether or not the agent should be forwarded, whether or not X11 should be forwarded, which SSH supports, but you can override any of these options by indicating options on the command line, whether or not rhosts RSA authentication is supported, etc. These are the defaults that are turned on. Password authentication is supported, hostbase is not. The identity files that are permitted are these: for DSA, RSA, and RSA version 1. The port that the SSH clients will attempt to connect to is port 22. The protocol version order is 2 then 1. However, this is governed by the server, and most servers should be, or your server should be configured to accept only version 2 of SSH because of security concerns with version 1. The various ciphers that are supported, but the default cipher is triple des. But here is a list of, or an array of ciphers that are supported in addition to the default triple des. Whether or not tunneling is turned on by default, the escape character to kill the session, which is tilde, etc. So these are options that are read by the client. Now we notice that host asterisk is mentioned here with no comment, and these are additional options that are turned on or off or set independent of the defaults that we've just covered. And as mentioned, there's also SSHD_config, which cannot be read by a non-privileged user and is read by the SSH daemon that's running. A PSEF grep SSH reveals that the primary daemon is running, and as it assigns pseudo terminals, you'll see multiple instances or